Understanding particle physics and exploring subatomic particles. 1. Introduction to particle physics. Definition. Particle physics is a branch of physics that studies the fundamental particles and forces that make up the universe. It explores the smallest building blocks of matter and their interactions. 2. Particle classification. Quarks. Elementary particles that combine to form protons and neutrons. Leptons. Include electrons and neutrinos. Bosons. Particles responsible for mediating fundamental forces, such as photons for electromagnetism and with Z-bosons for weak nuclear force. 3. Tools and experiments. Particle accelerators. Large machines that accelerate particles to high speeds. Examples include the Large Hadron Collider, LHC, at CERN. Detectors. Instruments that capture and record the results of particle collisions. Examples include ATLAS and CMS detectors at the LHC. Cloud chambers. Devices that visualize the tracks of charged particles by creating visible condensation trails. 4. Standard model of particle physics. Quark model. Describes the behavior of quarks and how they combine to form hadrons, protons, neutrons. Lepton model. Describes the behavior of leptons, including electrons and neutrinos. Boson model. Describes force-carrying particles, including photons and with Z-bosons. 5. Fundamental forces. Electromagnetic force, mediated by photons, responsible for interactions between charged particles. Weak nuclear force, mediated by with Z-bosons, responsible for processes like beta decay. Strong nuclear force, mediated by gluons, binds quarks together within protons and neutrons. 6. Explore antiparticles. Antiparticles. For every particle, there is an antiparticle with opposite charge. When they meet, they can annihilate each other. Positron-electron annihilation. An example of annihilation resulting in the creation of photons. 7. Particle decays. Beta decay. Involves the transformation of a neutron into a proton, electron, and an antineutrino. Muon decay. Muons can decay into electrons and neutrinos. 8. Dark matter and dark energy. Dark matter. Theoretical matter that does not interact with light, yet its existence is inferred due to its gravitational effects on visible matter. Dark energy. A mysterious form of energy causing the accelerated expansion of the universe. 9. Neutrino oscillation. Neutrino flavor change. Neutrinos can change between different types, flavors, as they travel, a phenomenon known as neutrino oscillation. 10. Cosmic ray interactions. High-energy particles. Cosmic rays from space can be studied as they interact with Earth's atmosphere, producing cascades of secondary particles. 11. String theory. Theoretical framework. String theory proposes that fundamental particles are not point-like but are tiny, vibrating strings. It aims to unify quantum mechanics and general relativity. 12. Quantum entanglement. Quantum phenomenon. Particles can become entangled, and the state of one particle instantly influences the state of the other, even when separated by large distances. 13. Participate in citizen science. Zooniverse projects. Engage in online citizen science projects related to particle physics. Projects like Particle Clicker allow participants to contribute to data analysis. 14. Stay informed. News and journals. Follow developments in particle physics through reputable news sources, scientific journals, and research institutions. 15. Pursue further education. Online courses. Enroll in online courses on particle physics offered by universities and educational platforms. Books and literature. Read books on particle physics, written for different levels of understanding. 16. Attend public lectures and events. Lectures and conferences. Attend public lectures, conferences, and events hosted by universities or research institutions to gain insights from experts. Particle physics is a dynamic field that continues to push the boundaries of our understanding of the universe. While some aspects of particle physics involve highly advanced theoretical concepts and experimental setups, There are various entry points for enthusiasts and learners to explore the fascinating world of subatomic particles. Whether through online resources, citizen science projects, or attending public events, there are ample opportunities to engage with and appreciate the profound discoveries in particle physics.